I'm working in Paris, and I have to thank Professor Ahmed Al-Saidi for organizing this Congress and for inviting me. It's a great honor for me. And so thank you very much for this very powerful meeting. I'm focused my professional activity in ophthalmic imaging, and we have opened 2 centers in Paris only dedicated to ophthalmic imaging. All patients are referred by other ophthalmologists in order to practice some imaging exploration. And so in terms of glaucoma, we practice many ultrasound examination and UBM, visual field, OCT and OCT angiography around the disc, and pachymetry, and we practice lasers too. Making this, we are very specialized in ophthalmic imaging, and we organize a congress each year. The next congress will be the 4th of October, and if you want to come, that will be my great pleasure to see you in Paris next time. UBM is part of angle analysis. You can see that with the previous talks, you have a very important point with the gonioscopy, and we have a high interest to go to dynamic gonioscopy. And we can take a photograph of the angle, and now we have other devices like the Nidec new device for providing complete angle imaging. But we now have many OCTs able to go to the angle in all our clinics, and ultrasound is another approach of the angle. We have had a few new research development on Artemis and ARC scan, but now we are using ultrasound devices that can be able to go to the posterior pole and to anterior segment with the UBM probes. What you can differentiate on this different approach with different devices is gonioscopy and angle photography gives you information on the reopening of the angle with dynamic gonioscopy and the color information of the angle. When you go to the OCTs and UBM, you have just meridian scan. It's not the same approach, it's complementary approach. When we use UBM ultrasound, focus on the angle, we can observe that the anatomy of the angle is very different from one patient to another, and we can see diverse anatomical situation. You can see that OCT have increased resolution, and you can observe what is the interest of OCT on the angle, but you can observe also the limitation of penetration and the visualization of the cerebral processes that are quite impossible. We can develop many measurements of the opening angle, but in current practice, we prefer to perform this kind of dynamic observation of the angle. You can put the probe or the OCT on one meridian scan on the angle, observe the angle with light condition, and make dark condition in the room, and you can observe directly the possibility of closure, of angle closure on this patient. You can see the limitation of penetration of the OCT on the same patient, and you can observe that with UBM, you can delimitate the borders of the cerebral processes. So in our current practice, we can observe many different situations of angle anomalies, and you can observe some congenital syndromes and some synechias, but we have to know that in gonioscopy, it's better to detect the goniosynechias. But in front of this situation of iris bowing, UBM is a perfect tool to have a solution of the mechanism of this iris bowing. You can observe just a cyst in one meridian or multiple cysts, and you will see that it can give problems for treatment. You can observe some dense lesion in the iris or a tumor in the cerebral processes. And you know that when you have a tumor in the cerebral processes, one first signal could be hyperpressure in this eye and not on the other eye. So pay attention to this difference of pressure in the eye and go to UBM in order to observe the cerebral processes. In terms of pigmentary glaucoma, you have seen that we have interest in some cases to perform a PI, and you can observe with OCTs and with UBM the response of the iris after PI, before and after PI. But in current practice, the main impact of UBM is in the field of angle closure glaucoma. And we can observe with UBM all the different factors of this mechanism of angle closure. We can observe anterior chamber depth. We know since many, many years that anterior chamber depth is a main factor. But we can observe also the lens factors. And the lens factors are divided in two. We can describe the lens vault, and we can describe the lens thickness. You'll see other examples. Pupillary block is, in fact, the reaction in dark condition. Plateau iris mechanism can be clearly defined by the UBM, and we can differentiate plateau iris from cyst and from anterior insertion of the iris root. You can see on this slide the importance of the lens factor in case of acute glaucoma. And we can draw a line between scleral spur to scleral spur and just notice the distance between this line and the anterior pole of the lens and get the measurements of these lines. In our current practice, this mean value is 670 microns. If you go up to 1,000 and more, you know that we have a very important lens factor that can lead to malignant glaucoma in few situations. Plateau iris mechanism can be diagnosed and defined by UBM by these 3 points. You can see the angle in dark condition with UBM. You can observe that we have angle closure. We can detect this scleral spur with the intercept of both curvatures of the sclera and the cornea. And you can observe this scleral spur and observe the positioning of ciliary processes to the right or to the left of this landmark. And you can observe that we have no ciliary sulcus. This is our definition of plateau iris mechanism. But by seeing many, many patients, we can observe that we have another mechanism in order to close the angle. This is the anterior insertion of the iris root. You can observe this very small distance between the scleral spur and the end of the peripheral limit of the iris epithelium. And without this insertion, you can observe the difference. In few cases, we have combination of these 2 factors, anterior iris insertion and plateau iris. And so it's better to know how is the situation of this patient before proposing one treatment on another. But UBM can have a very interesting approach after treatment, and especially when PI have not reopened the angle. You can observe 2 different situations. On the left, you can observe a large PI, very well visible on these scans. And on the right, you can observe a very small PI. But one key point to observe the efficacy of the PI is the shape of the iris. You can notice on the right that you have the iris bowing despite this treatment with PI. So probably this PI is not complete, and so you have to treat the patient again. You have another example of failure of the PI. In this case, you have multiple cysts, and you can observe on the slide below that the PI is opening in a cyst, and so you cannot have the effect of the PI by passing through the PI, the aqueous humerus. You can observe another failure of the PI in case of plateau iris. You can observe the scleral spur, and you can understand that the anterior positioning of the ciliary processes are pushing the iris root forward and closing the angle despite of a large PI. You can observe that we have PI not so, a little bit in the periphery of the iris, and you can observe that the ciliary processes can block the efficacy of the PI in case of plateau iris. If we go to the complementary treatment of a plateau iris, we go to iridoplasty. You have seen the presentation with the previous speaker, and you can observe that we have a thinning of the iris root due to the treatment by laser. But in other cases, you can observe the thinning of the iris root, but the the angle remains closed because probably the thinning of the iris root is not so much efficient, or we have impact not so peripheral. And so we probably have to move on iridoplasty to produce impacts just on the iris root in order to compensate this plateau iris mechanism. Just to show you the importance of the lens factor, you can observe that the very important lens factor with this more than 1,000 microns lens volt, the result before surgery and after surgery, in this case of plateau iris. And you can observe that we have reopening the angle, and these ray processes have moved forward. With UBM, we can also follow the filtering surgery. You can observe the difference between trabeculectomy and deep sclerectomy when we are able to observe the trabeculum in the angle and the response with the conjunctival bubble that seems to be functional because she's very dense and she's working like a sponge. So in our hands, we know that UBM is not a very, very common machine and a very, very common device, but we have produced 3 wet labs in this conference, and we hope that in each country we will have 1, 2, or more specialists in UBM in order to give you all the responses when you have no positive response of your treatment in case of narrow angle. Because with UBM we have deep penetration, and we can observe the angle in dark conditions. This makes a great difference. When we practice gonioscopy with lights. When we practice observation of the angle with OCT, we have infrared lights, and we have not the same response than with UBM in dark condition. And so we can get great advantages to go to the anatomy of the angle, including Seray process anatomy and lens factor. We can help with UBM to better analyze the glaucoma mechanism and decide for the treatment. And in case of not reopening of the angle, we can go to UBM to understand why we have the failure of this treatment. I thank you very much.